So let's go ahead and we're going to talk about discrete random variables. So remember, when we talk about discrete, that means that we're using numbers that we can count with. So if you have a hard time with that, go back to the types of data and refresh that. So remember, discrete numbers are numbers that we don't really have decimals or fractions in. So let's look at this. So a random variable describes the outcomes of a statistical experiment in words. So the values of the random variables can vary from the repetition of the experiment. So we're talking about here, we're like rolling a dice, tossing a coin, those kind of things. So upper letters such as X or Y denote a random variable. And lowercase letters like that lowercase x or y denote the value of that random variable. So think about it this way. Uppercase talks about the variable itself. Lowercase talks about the value of that random variable. So if uppercase X is a random variable, then X is written in words and the small x is given as a number. Right. So when we talk about the probability distribution function, PDF, for a discrete random variable, we're going to have two things. Each probability has to be between 0 and 1, and the sum of the probability is 1. So what does that mean? So that means that when we have a probability, say the probability it's going to rain. So usually you see it's like 60, 70%. We can convert that to a fraction. So it would be 0.60 or 0.70. We're never going to have the probability that it's going to rain over 100%. Or we're never going to have the probability it's going to rain is negative number. It's always between 0 and 100%. It's the same for this. Think about it. I'm just converting the percentages to decimals from 0 to 1. And again, anytime I have probabilities of something happening, it has to add up to 1. So let's look at this example. A child psychologist is interested in the number of times a newborn baby cries waking up its mom after midnight. So they sample 50 moms and they get the following information. Let the capital X be the number of times per week a newborn baby's crying wakes its mom up after midnight. So this is no times it occurred, 1 time, 2 time, 3 time, 4 time, or 5 time, okay? So again, we're letting these be the number of nights that the baby woke the mom up, okay? So that's what that table means. All right, and so let me keep going. Okay. So again, it's the values were 0, 1, 2, 3, or 5, and it's a discrete PDF because we gave each P with the X is between 0 and 1. And if we go back, let me show you. So this was the results they got. So let's do this. 2 out of the 50 babies woke their moms up. 0 nights. So that means out of this whole sample of 50, only 2 babies didn't wake their moms up. So 11 out of 50 means 11 of the babies woke their moms up 1 night a week. Just that 1 night. The 23 over 50 means 23 of the babies woke their moms up 2 nights. And here, 9 of the babies woke their moms up 3 nights, 4 woke their moms up 4 nights, and 1 woke their moms up all 5 nights. Okay, so that's what that means. So again, the 2 over 50 means 2 babies out of the 50 babies didn't wake up at all. That's what we're looking at. Again, 0, 1, 2, 3, 4, 5 is the number of nights. This over here talks about the part of the baby or the percentage of the babies or the number of the babies that woke up versus the total babies compared to that night. Okay. So the sum of that is going to be 1. And if I added all those values up, it makes 1. So again, it's between 0 and 1, and all the probabilities add up to 1. Okay, so let's do a practice. Suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days, 15% of the time, 1 day, 4% of the time, and no days, 1% of the time. Suppose 1 week is randomly selected. So let the capital X be the number of days Nancy went to school. X takes on what values? Okay. So I'm going to say the number of the days of the schools is my capital X. So X is going to take on what values? I'm given 80%, 15%, 4%, and 1%. Okay, so there I have my numbers. So construct the table. So let's go construct this table. Okay, 0 days, 1 day, 2 day, 3 day. And all I did here is I just converted those percentages to decimals. And the good thing is because this adds up to 1, I don't have to put it over 1 each time because it's given. Okay. And again, that's what you see. All right.